Hello everyone. So today I want to show you the basic refactoring techniques that we can apply in any code base to improve its design. And for that I want to introduce this little class here, which is a circle. And the circle here has a method on it which is called count contained points. So basically you can ask the circle to calculate which of the points that are represented here as two integer arrays for x coordinates and y coordinates. You can ask the circle how many of these points are contained within it. So besides some validation checks, at some point we iterate over these coordinates, and for each of the coordinates we evaluate if it is contained, and in the end we return the number of contained points. Interesting here now is the evaluate method, and the evaluate method actually takes these two integer arrays and it takes the index, and from this it creates the result. Whatever the result is, probably it means if the point is contained within the circle, and if it is contained, then it will increase the number of contained points. Now, of course, this is not the best design, and we can actually improve this design with the 5 refactoring techniques I want to show. So the first one of these refactoring techniques is actually rename. Rename is the most powerful of all the refactorings because it can give us context and meaning in otherwise very hard to understand code base. If we look inside here, we see that we have this cx and this cx again, and this cy, this cy again, and we have r. In the context of a circle, this c probably refers to the center point of the circle. And on the other hand, we have r, which is probably the radius of the circle. So we can directly rename those things with, for example, to center. And then it also asks us if we want to rename some parameter. So yeah, why not? And then we run our tests. So this is very important, that after each refactoring, especially if we're not sure if this refactoring was safe that we just did, that we run our tests. The rename, of course, should be rather safe, but we never know. So after we have renamed this, we can directly commit this small change. For example, rename C to center. And then we have already a new baseline where we can revert to should another refactoring go wrong. So the next thing would be to rename r to radius. It also asks us if we want to rename another parameter. We run our tests again and we commit. Rename r to radius. Great, so we already improved the naming of these variables here. But now let's continue. The next refactoring I want to show is actually extract variable. And we see here that we have this duplication of x coords minus center x and x coords minus center x again. So I will extract the variable for this little part here, and I will call it delta x. So the IDE already proposed to replace both duplications with this variable, and again I can run my tests and I commit. Now I do the same also for this part here, which is delta y. I run my tests and I commit. Okay, now we already see a bit better how this actually works. So we see we square this part here, we square this part here, and we square this part here. And if the squared part of the point coordinates is smaller than the radius squared, apparently then it's contained within the circle. And we can make that a bit more explicit, for example, by extracting a method. So this is the next refactoring. We extract a method for these calculations of the square. So for example, I can extract it like that, call it square. And now the IDE might ask me to replace other occurrences of that duplication, which I actually want to replace. So it says here the radius times radius is exactly the same. Well, let's replace it. We also see here that it didn't replace the delta y times delta y, so we need to be careful. Our IDE is not perfect, but I will do the same here as well. Delta y, run my tests, commit, and I call this extract method for squaring. But now let's continue a bit more, and we actually see here that we pass this very ugly x coordinate and y coordinate into this method. So somehow it would be actually much nicer if we also had a point, like for example, if we look at the center, we have a point, and actually pass a point into the method to be able to see the difference between the center and this point, and not this primitive x coordinates. So I will do this now by creating a new point where I pass basically the entire x coordinates I and y coordinates I in. And I will start actually by extracting a variable for this x coordinate. I just call it x coord. And also this one, it's y coord. And I can rename that later. And now I create my new point with the two variables in it. I see I have this point, it's that code at the moment. But now I actually want to change, I want to now I actually want to replace this x coordinate and y coordinate with point.x and point.y. How can I do that? Well, with a little bit of inline magic, I can first replace only this occurrence with the array and exactly the y coordinate also with the array. Run my tests, okay, everything is green. And now I move my point up here. I replace this one with x, inline it, run my tests, and I have replaced the x with the point x, and I do the same for y, and I inline this, run my tests, and now I'm fine. Now I've replaced these ugly coordinates with a point. But now I actually also want to pass it in. So let's go ahead and extract the method for the entire calculation of the contains part. So is this point contained within the circle? So I can actually already call this contains, which is a great method which you would expect actually on a circle, that you can call the circle and ask it, do you contain this point? Then I can clean up a bit. For example, I can remove this variable by inlining it. So you see how important actually this inline is. And I can do the same up here. I can just press Command, Option, and N. So you always see up there in the right corner, you see how I do it. And now we have inlined everything. Of course, we need to run our tests, and we are green. Now let's commit, extract method for containing a point within the circle. And now we can continue. So now we have split the part that checks for containment from the part that actually counts the number of contained points. And we also have created this point here that makes the parameter list of contains much easier to read. Now we can actually think about inlining this evaluate method. And the little trick here is that when we iterate over these coordinates, we're not going to refactor these x coordinates and y coordinates into a list. I will do that in another video. But for now, we actually do two different things here. So on the one hand, we create a point and we also increase the number of contained points. So we do a third thing. Basically, we also check for the containment. And I actually want to first map it to a point before I execute this part. So I briefly changed back this streaming API to a loop. I can briefly run my tests again. And then I automatically will collapse this again into a stream. And now you see what happens. Actually, IntelliJ is intelligent enough to know that what I want is to first map to this object, to this point, then filter with the contains method, and then if it's contained, then increase the number of contained points. This is still not great design here, and in a future video I will show you how to improve on that. But now, for now, I just focus on this contains method. And you see the test still works, so I can also commit this part to split loop into different concerns. And now I basically have extracted a much better readable method that also takes a much stronger type than these x coordinates and y coordinates. And I can basically say, well, I'm already done. But now I also want to show the move, why move is so important. So I've showed you how to rename, how to extract a variable, how to extract a method, and also inline both variables and methods to reevaluate certain refactorings. Maybe you did something wrong or want to try another version of the design. So inlining is very important. If you don't have inline, you cannot do that easily. But now we can actually also experiment a little bit. So my tests are green. I can also, if I want to make sure that everything actually is covered by tests, I can also run the test coverage here and see if my code is covered. You see here, it is actually covered quite well. So I can assume that my test suite is rather complete, or at least I hope. So now I can think about a bit about the design. So what do I do here actually? So I take the square of the x coordinates, I take the square of the y coordinates of the 2 points, and I compare that to the square of the radius. So if we write that a little bit differently, we can also say, well, it's actually the distance between the 2 points that needs to be smaller than the radius to be able to say, well, this point is contained within the circle. So I can start actually to refactor it by changing also a bit how this calculation is performed. So for example here, I can call this distance between, for example, and probably we also need to specify it as the distance between points squared, just for now. So we extracted a variable again, nothing special here. For the square, if we want to be super fancy, we can also say, well, we use math.power and actually use this built-in method to calculate the square. But now let's focus on this part here. So we have the radius, which is squared, we have the distance between the points that is squared, and now we need to take the square root to actually get to the one-dimensional version. So instead of having radius squared, we can remove this and take the square root of the distance between the 2 points. And now this was very important. I use a little bit different methods than before, but because I still have my tests in place and they cover all my cases here, I'm quite confident that this change will actually not break anything. And now we have actually arrived at a point where we can extract yet another method that might make sense on a point, and I want to show you that. I extract a variable for this part, which is basically the distance between points, not squared anymore. Now I might be inclined to inline this part again, and I see that actually works. I can run my tests again, all fine. Maybe I actually don't need this square method, so I can inline that as well. And now I'm at this point where I can say, well, actually, the distance is calculated in these 3 um, lines of code. So I extract another method. I call it distance to point. And I run my tests again. It still works. Let's clean up a little bit this part. So I have inlined it. And now I still have the issue that I depend on the center. So I will extract a variable for the center point here, call it something like point 2. I run my tests again. I take this part down here and wrap it in another method. I call distance to number 2. I inline my point again, and I inline my outer method again. I run my tests, and everything still works. So now I have this distance 2, which I can rename to distance 2, and basically move it to these points. I still have the problem that it's static, but for now I will just remove this static. There's no harm in it at the moment. And now I can move it. So let's call move on this. And I say I take one of the points, it doesn't really matter. I say I make the visibility public because I expect distance to be actually quite useful method on this point class, and I move it there. Now I see here that the point distance to the center is actually called correctly. So let's see what the test says. Everything still works. So I can inline this variable again. And if I want to be a bit clear that I actually check the distance to center, maybe it makes sense to have center here and have the distance to point like that. And you see my tests always give me feedback if I broke anything. And now let's see how the distance to method actually looks. So we have our record here, which is a point which didn't have much functionality, but now it actually has some functionality, which is quite useful actually. So in the context of a circle and points and geometric forms, it absolutely makes sense that this domain actually also has some methods and functionality on it. And this is the first step to move towards a more rich domain model, which also gives you something, which doesn't only hold data and then you need to fetch all the methods and functionality from somewhere else, but you actually have a class that also gives you some form of functionality. And you see that now I actually have changed quite a lot, but the tests didn't break, so I'm quite confident that my changes don't introduce any bugs. and I only used rename, move, extract variable, extract method, and also inline. So I encourage you to get an IDE that supports these kind of refactoring techniques and practice this flow of inlining, extracting, renaming, moving over and over again. And then you get much faster and you see how quickly you can change the entire code base by using these refactoring tools. That's it.